For topic 4, we're going to determine if vectors are parallel. So we first have to kind of talk about what that means, because it's a little bit different than just saying, hey, two lines are parallel means they never intersect. That's not exactly what it means with vectors. So for the definition, as I've said, I love a good definition at the start of a video. But the definition here is vectors that are moving in the same direction or opposite directions are considered parallel. Okay, this means the angle between the vectors would be either 0 degrees or 180 degrees. Let's talk about that. Okay, so let's say we have this vector. Okay, and then let's say we have this vector. Okay. They're appearing to travel in the same direction. And that would be true. If I take this little vector over here and I kind of lay it on top of the big vector. So if I take the little red vector and I lay it on top of the black vector, you can see here they are for sure going in the same direction. And what I've done is I've lined them up so they share an initial point, and you can see that the red vector lies on top of the black vector. They are definitely going in the same direction. You can also see that the angle between is, well, 0 degrees. Okay? So when two vectors travel in the same direction, you could basically put one on top of the other, and the angle between them would just be, well, 0. Okay? Now envision another situation where we have maybe, let's do purple and blue. So let's say I have this vector that's chilling out going this direction, but then let's say I have this vector that shares that same initial point. We're going to do that just for funsies, and it's going in this direction. Well, if we make them share the same initial point, what do we notice about the angle between them? Well, the angle between them would end up being, well, 180 degrees. Okay. So we have two vectors that are traveling in opposite directions. They are considered parallel, and they're going to have an angle between them of 180 degrees. You can also have vectors that are traveling in the same direction, and the angle between them would be 0 degrees. Okay. So we can really just test that. We can pretty easily test to see if two vectors are indeed parallel. Okay. Now we do want to remind ourselves of a couple of other things. It does say here that further, okay, I love when we use real fancy schmancy words like henceforth, further, thus, okay? Further, if two vectors are parallel, then one is going to be a scalar multiple of the other, okay? And that's what this is saying right here, okay? So basically, one is a scalar multiple of the other. And we can see that if you look at the red and black vectors that I drew initially, we can see that the little short red vector, okay, if it lays right on top of the black vector, you can see that the black vector is definitely a scalar multiple of the red vector. It's just the red vector elongated, okay? You could also say that the red vector is a scalar multiple of the black vector. It's just the black vector, but shortened, okay? So when you do have two vectors that are parallel, we can say that one is a scalar multiple of the other, okay? Now, ooh, did I give myself enough room? Ooh, I don't love that I didn't give myself a ton of room here. Is it going on to the next page? Yeah, it's going on to the next page. That's all. I was like, oh no. Okay. So what I'm going to do is I'm going to scoot this down a little bit further because it is going on to the next page. And I was like, that can't be good. Let's do it. I want to be able to do this in one piece, so I'm going to scoot it down to the next page. There we go. Okay. So it says here for example 6, hopefully your printout doesn't look like that. But here for example 6, it says use the vectors v and w to answer the following questions. Okay, so we have that v equals 4i minus 8j and w equals negative 2i plus 4j. Okay, so if you want to, you could rewrite these. You know, I've mentioned this just about every video. I like them as position vectors. It's easier for me to see what is going on. So I don't like component form because I feel like the I's and J's just get all cluttered in my brain. Okay, so part A says find theta using the angle between vectors theorem. Are the vectors parallel? Let's first just kind of start by plotting these. Let's see what happens if we sort of just draw these vectors and see what's happening visually. Okay, so let's say I had to look at my picture to make sure I give myself enough room here. All right, so for V, let's do V in blue. We have a horizontal movement of 4. We have a vertical movement of -8. So I'm going to go to the right 1, 2, 3, 4, and then down 8. So this is completely freehand. Please keep that in mind when you see the final result here. Now W has a horizontal movement of -2 and a vertical movement of +4. So I would go to the left 2, and then I would go up 4. So that would be about here. So that would be this vector. So looking at these two vectors, keeping in mind that I drew this completely freehand without actual grid or graph paper, they do appear to be parallel, okay? So they appear to be parallel. But you can't just look at it and be like, yeah, I think they look parallel. You really need to test this and make sure that they're for sure parallel, okay? So we know a couple of things here. We know that we can find an angle between vectors. And if we find an angle between vectors and it's either 0 degrees or 180 degrees, we can say, hey, these things are definitely parallel, okay? So please recall that if we have cosine of theta, it is, what are our vectors, v and w? So cosine of theta is equal to v dot w, so the dot product of your two vectors, divided by the product of their magnitudes, okay? All right, so what we're going to do is we're going to find the dot product, we're going to find the magnitudes individually, and then we're going to kind of like plug it all into this formula, okay? So I'm going to leave myself a little bit of space. So I'm going to say, okay, V dot W. We want to take the A components, multiply them, the B components, multiply them, and then add. So for the A components, we get 4 times -2. The B components are -8 times 4. So let's see, 4 times -2 is -8. 8 times 4 is -32. So you should get -40. So I'm going to go ahead and plug -40 for the numerator of this mess that I have up here. Okay? Now I want to find the magnitude of V and the magnitude of W. So let's start with V. So the magnitude of V, remember, is going to be the square root of the A component squared plus the B component squared. So that's going to be 4 squared plus -8 squared. So that is going to be 16 plus 64. So that's what, 80? So we get the square root of 80, which we can clean that up a little bit. The square root of 80 is actually 16 times 5. Well, the square root isn't. 80 is 16 times 5. So this would equal the square root of 16 times 5, which would just be 4 square root 5. Okay? So I get 4 square root 5 for the magnitude of V. Now let's look at the magnitude for W. My pen is squeaking and it's like driving me crazy. I hope you all can't hear it. Okay, so the magnitude of W is the square root of its A component squared plus its B component squared. So -2 squared plus 4 squared. So that's going to be 4 plus 16. So that's the square root of 20, which I could rewrite as the square root of 4 times 5, which is 2 square root 5. So let's kind of think about what this is going to do. If I have 2, and I'm going to do a little side work here, and I'll do it in red just so you can understand. So if I have 4 times the square root of 5 times 2 times the square root of 5, I can take the 4 and the 2 and multiply them, and then I can take the square root of 5 and multiply it by the square root of 5. Well, 4 times 2 is 8, okay? And then the square root of 5 times the square root of 5 is 5. So this really just equals, well, 40, okay? So I can rewrite this as cosine of theta equals -40 over 40. So that means cosine of theta equals -1, okay? And you can either think about this logically or you can like do the work. We can take cosine inverse or inverse cosine of each side. Okay. And when I do that, it's going to free the theta from the argument. So we would end up getting theta equals inverse cosine of -1. So let's just kind of stop and think about that. If you go to a unit circle, okay, so envision a unit circle. All right, we're basically looking for the angle that gives us a cosine ratio of -1, okay? Well, if I go exactly 180 degrees, so this is pi radians or 180 degrees, okay? If I go exactly that far on the unit circle, I'm going to have a point on my unit circle of -1, comma 0, okay? So we know that cosine is the x-coordinate here. Okay, so what angle gives me a cosine ratio of -1? Well, this tells me right here that theta would equal pi or 180 degrees. Okay, so let's hold on to that. I'll highlight it to make it, dadgummit, I did it again. I'll highlight it to make it super, super clear while I scroll up. Now remember, we first were told, where is it? Right here. We were told that two vectors are considered parallel if they're in the same direction or opposite directions. And essentially what that means is their angle between them has to either be 0 degrees or 180. And we have a situation here where the angle between two vectors is definitely 180. So we have verified for sure that these two vectors are parallel. Okay? So I wish I'd given myself a little more room. I'm really bad about that. I'll either give too much or way too little. I rarely get it just right. Okay? Now for part B, it says rewrite vector v in terms of vector w. That is, show that vector v is a scalar multiple of w. Okay, so let's really sit and think about this. Okay, so we already know that vector v has components of 4 and 8. So it has a horizontal movement of 4 units and a vertical movement of 8 units, -8, put a negative there. And then we know that vector W has a horizontal movement of -2 and a vertical movement of +4. So is there a relationship here between these two vectors? Okay, well, the answer to that is for sure. If I take vector W and I multiply both components by just 2, well, I would get the 4 and the 8 that I have in vector V. The issue is the direction on both of those movements would be wrong, okay? So if I take 2 times vector W, I would get -4, comma 8. Well, that's getting kind of close here, but the directions are wrong. So how else could I potentially write W? Well, what about -2 times the vector W? Well, if I did that, I would take each component of W, multiply it by -2. Well, -2 times -2, and then -2 times 4, that would give me 4, comma, -8, which is exactly equal, okay? So I could basically say vector V is equal to -2 times vector W. So I have now shown that V is a scalar multiple of W, okay? So remember, if two vectors are indeed parallel, one's going to be a scalar multiple of the other, okay? So we have just like double proven that these two vectors are indeed parallel. Okay, in the next video, we will talk about vectors that are orthogonal, which is just another way of saying perpendicular.